This is a Ford-class nuclear-powered aircraft carrier, which is currently the largest and most powerful aircraft carrier in the world, as well as a symbol of the strength of the U.S. Navy. As an aircraft carrier, the most important attribute is its ability to carry aircraft. The Ford class can carry more than 75 aircraft, including 2 squadrons with about 12 F-35C aircraft each, 2 squadrons of F-18 Super Hornets, 5 EA-18G Growler electronic warfare aircraft, 4 E-2C Hawkeye early warning aircraft, 2 C-1 Greyhound transport aircraft, and 8 MH-60 Seahawk helicopters. To accommodate such a large fleet, the aircraft carrier is naturally huge. The Ford class is 337 meters long, 77 meters wide, and 78 meters high, equivalent to a 26-story building, with a full load displacement of 110,000 tons, making it a true floating island. In addition to the US, France is the only other country with a nuclear-powered aircraft carrier. Compared to their flagship Charles de Gaulle, the Ford class has 2.67 times the displacement. If we compare the cost, it's even more staggering. One Ford-class aircraft carrier costs $13 billion, which could buy 6 Charles de Gaulle carriers, with some change left over. This massive vessel requires immense energy supply. The Ford class is equipped with 2 AEB nuclear reactors, which provide a total output of over 1,400 megawatts, acting as the energy heart of the carrier, driving its 4 5-blade propellers, allowing the ship to reach a top speed of over 65 kilometers per hour, making it the fastest aircraft carrier in the world. The nuclear reactors also supply electricity for all the ship's facilities, with a total power generation capacity 3 times that of the previous Nimitz-class aircraft carrier. The U.S. Navy expects the Ford class to serve in the fleet for around 90 years, until 2105. This also means that during the future upgrades, there will be many technological modifications. Therefore, only half of the power is used for the current systems, with the other half reserved for future upgrades. As the pillar of the U.S. Navy for decades, what unique features does the Ford class possess? Welcome to Chris's military base, focusing on military equipment from various countries. Today we're discussing the maritime powerhouse, the Ford-class aircraft carrier. The Ford-class aircraft carrier originated in 1975, when the first Nimitz-class carrier was just beginning its service. The U.S. Navy started developing a series of concept proposals for the next-generation aircraft carrier named CVNX, which covered small, medium, and large aircraft carriers, involving a total of 15 different ship sizes, with takeoff methods ranging from catapult launches to ski jump launches. Each method included both traditional deck layouts and new designs. In total, there were more than 50 design proposals. However, Americans have always favored larger aircraft carriers that can carry more, so the final design followed the layout of the Kitty Hawk class, but with innovative technologies applied to other key areas of the carrier design. On August 11, 2005, the construction of the first Ford-class aircraft carrier, CVN-78, began, taking 8 years to complete. In November 2013, the first Ford-class ship was officially launched. Afterward, a long testing process began, lasting another 5 years, and in July 2017, it was commissioned into the U.S. Navy. From the outside, the Ford class may look similar to previous aircraft carriers, but there are some differences inside. The position of the island on the Ford class is different from that of earlier carriers, being located closer to the rear of the ship. This allows more aircraft to park in front of the island, speeding up the operations on the deck. As a result, the island on the Ford class is also smaller. Compared to the 30-meter-long island on the Nimitz class, the Ford class has only an 18-meter-long island, providing extra usable deck space. In front of the island, there is a 25-meter-long elevator that can move aircraft from the hangar to the deck. The elevator is located on the side of the aircraft carrier, so its operation does not affect the takeoff or landing of aircraft. Apart from the elevator in front of the island, the Ford class has 2 more elevators located on each side of the carrier. The location of the elevators is very well thought out. Early aircraft carriers had their elevators located in the center of the deck, which could leave a large hole on the deck if the elevator failed, disrupting aircraft operations. So, as aircraft carriers evolved, elevators were moved to the sides, but their positions remained critical. For example, on the U.S. Navy's first post-World aircraft carrier, the Forrestal class, there were 4 elevators, but the left front elevator, due to the inclined deck, interfered with the work of the 2 catapults behind it. This issue was resolved on the Kitty Hawk class, with the left front catapult being moved to the end of the inclined deck, and this layout was continued on the Nimitz class as well, with 3 elevators on the right and 1 on the left. Ideally, more elevators would increase the efficiency of transporting aircraft, but on the Ford class, the configuration was changed, removing 1 elevator on the right side, which actually improved efficiency. This was because, on the Nimitz class, refueling, maintenance, and ammunition loading were done in different locations, and aircraft often had to move around the deck. On the Ford class, engineers redesigned the ammunition supply and refueling processes, optimizing the workflow, and focusing on specific areas, so there was no need to move aircraft frequently. Compared to the Nimitz class, operational efficiency was increased by 25%, and the number of deck crew was reduced by about 25%. Unlike any previous U.S. Navy aircraft carrier, the Ford class uses electromagnetic catapult technology, replacing the traditional steam catapults. Steam catapults had to be set to different parameters for launching different types of aircraft, which slowed down launch speeds and increased workload. At the same time, due to its complex mechanical structure, steam catapults were prone to corrosion and required frequent maintenance and large amounts of fresh water. In contrast, electromagnetic catapults are simpler in design, require only electricity to operate, and can automatically adjust parameters based on the aircraft type, enabling smoother and more efficient launches. Another advantage is that steam catapults use high-temperature steam to propel aircraft, which lacks acceleration control, causing high acceleration at launch, which impacts both the aircraft's structural lifespan and the pilot's health. Electromagnetic catapults are more controllable, providing smoother acceleration, reducing the shock experienced by both the aircraft and the pilot. When the engines are at afterburner, a large electric current passes through electromagnets on the launch rails, generating powerful magnetic forces that can propel an aircraft to 240 kilometers per hour in just 3 seconds. The maximum payload for launching aircraft has also been greatly increased. The overall launch efficiency is 25% higher than the Nimitz class, allowing for up to 160 sorties per day and up to 270 sorties on the highest days. The arresting gear used during aircraft landings also incorporates innovative designs. This system, known as the Advanced Electromagnetic Arresting System, includes turbine motors installed in the arresting gear below the deck. When the aircraft hooks onto the cable, it drives the turbine, absorbing 2/3 of the landing energy and converting it into electricity for backup. Compared to traditional hydraulic arresting gear, this system is more flexible. During landing, the computer automatically adjusts the resistance based on the aircraft's kinetic energy within 2 seconds, reducing damage to the aircraft's structure. However, currently, both the catapult and arresting gear systems are not performing perfectly. The electromagnetic catapult fails on average every 614 launches, achieving only 15% of the Navy's required failure rate. The arresting gear performs even worse, failing every 460 cycles, which which only meets 3% of the preset failure requirements. In terms of self-defense systems, the Ford class is equipped with two Mk-29 missile launch systems, each capable of loading 8 upgraded Sea Sparrow missiles, and 4 Mk-49 launch systems, each capable of loading 21 rolling airframe missiles. In addition, there are 4 close-in weapon systems, CIWS, for close-range defense against incoming aircraft and ships, as well as 4 M22.7mm machine guns. However, in future improvements, the Ford class is likely to be equipped with an electromagnetic railgun. In land tests by the U.S. military, this gun can reach a range of 200 kilometers and fire projectiles at speeds up to Mach 7. The gun's penetration power is immense, and its performance is excellent. However, the electromagnetic railgun requires a large energy supply and extensive cooling for the barrel and superconductors to generate the strong magnetic fields necessary to launch the projectiles. Therefore, it is impossible to deploy it on smaller units. Only ships like the Ford class, with huge power reserves, can meet the requirements. However, the weapon system of the aircraft carrier typically doesn't come into play. Take the first deployment of the Ford class as an example. In October 2022, the first Ford-class aircraft carrier crossed the Atlantic Ocean from North America to Europe for military exercises with NATO countries. The carrier battle group included the Ford-class aircraft carrier, a Ticonderoga-class missile cruiser, 4 Arleigh Burke-class destroyers, a Legend-class patrol ship, 2 fleet supply ships, and 2 ammunition ships. The Ford-class aircraft carrier is not only a technological marvel, but also a symbol of the U.S. Navy's dominance on the high seas. It represents a leap forward in carrier design, integrating cutting-edge technology like the electromagnetic catapult and advanced arresting gear. These advancements drastically improve the operational efficiency and safety of aircraft launches and landings. Additionally, its ability to carry more aircraft and sustain longer operations with reduced crew makes it a force multiplier for any naval operation. The Ford class also features an advanced self-defense system, including powerful radar and missile defense systems that ensure the ship can protect itself in high-threat environments. The integration of artificial